Okay, in this video, we're going to be looking at the gravitational potential energy worksheet. And just a quick note, if you didn't see it on the assignment, we're not going to be doing all of these because it's kind of overkill, but we're looking at gravitational potential energy. And really quickly, remember, gravitational potential energy is equal to the mass of the object times the acceleration of gravity times the height. Now, I did want to talk briefly about this because we've seen this mg before as well. This mg is equal to the force of gravity. So the other way that I could write this is that it's the force due to gravity, so F sub g times the height as well. And at the end of the day, that's force times distance, which means it's still the work done. In this case, the work done against gravity. So if we look at number one, it says a world record for pole vaulting is 6.15 meters. Pole vaulter's gravitational potential is 4,942 joules. What's his mass? So on this one, again, I'm going to go with the givens. So I know the height is equal to 6.15 meters. And I also know that the potential energy, PE, is equal to 4,942 joules. We also know that we're dealing with the acceleration of gravity here, because it's potential energy due to gravity. So 9.81 meters per second squared. So the equation I'm looking for, I want to find mass. Mass is my unknown. So I'm going to use the PE is equal to mgh. So 4,942 joules is equal to the mass, that's what I'm looking for, times 9.81 meters per second squared, times my height, which was 6.15 meters. When I solve for that, I multiply through by the 6.15 and the 9.81, divide through on the other side, and it gives me a mass of 81.9 kilograms. Now, number three, it says one of the largest planes ever fly, largest flying frequently, is the Antonov Rousselon. Wingspan is 73.2 meters, and length is 69.2 meters. Gravitational potential energy associated with the plane, altitude, blah, 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 is okay. So again, writing down everything I know the height. Now, initially, I've got 1.45 kilometers, and immediately as soon as I write that, I get a sick feeling in my stomach going, oh, something's not right. Now, remember, we live in an MKS world, so meters, kilograms, and seconds. So immediately, I'm going to change this from the 1.45 kilometers to 1.45 times 10 to the third meters, and get that right into meters right now. It also tells me the potential energy is equal to 3.36 times 10 to the ninth joules. And we know also the acceleration of gravity, 9.81 meters per second squared, and we're looking for the mass. So again, same equation, same dealio. We got mass, potential energy equal to mgh, potential energy 3.36 times 10 to the ninth joules. And that's going to be equal to the mass, that's what I'm looking for, times 9.81 meters per second squared, times my height, and that's 1.45 times 10 to the third meters. So again, multiply by 9.1 to 1.45, take that, and divide the 3.36 times 10 to the ninth by it, and so we get a mass of a roughly 2.36 times 10 to the fifth kilograms. So that's how we can solve for mass. We know the potential energy, gravitational pull, acceleration of gravity, and height. If we look down the next one, so we're going to do 4 and 6 on this one. It said 1993, said the world record for high jump, gravitational potential energy associated with Sotomayor's jump was 1,970 joules. So I know the potential energy is equal to 1,970 joules. And mass was 82 kilograms. And we also know, again, acceleration of gravity, 9.81. We're here on Earth, meters per second squared, and we're looking for the height. So I'm going to go PE is equal to mgh. Again, important to write down all my givens, and then my unknown. Find my equation, potential energy, and now I'm going to substitute in values with units. So 1,970 joules is equal to 82 kilograms times 9.81 meters per second squared. And then I solve for height. And my height kicks out to be 2.45 meters, approximately. The next thing we're going to do is number 6. The largest plane ever built is the Hughes H-4 Hercules flying boat. Again, 97.5 meters wingspan. It's still 9.1 meters longer than the next largest plane ever to be built. Made of birch, not spruce, is spruce goose. And, okay, gives us the mass is 1.81 times 10 to the fifth kilograms. So I'll write that down. Mass, 1.81 times 10 to the fifth kilograms. And they know should for a distance of 1.6 kilometers. How much potential energy is associated with 3.78 times 10 to the 7th? So we know the potential energy is equal to 3.78 times 10 to the 7th joules. And we also know the acceleration of gravity is 9.81 meters per second squared. Now you notice they give us a lot of extra numbers. They told us its wingspan, how much longer it is, the flew what distance. We got to be able to discern what's important and what's not. So we're looking for height. How high up did it fly? So potential energy is equal to that mgh again. So potential energy, so 3.78 times 10 to the 7th joules is equal to my mass of 1.81 times 10 to the 5th kilograms times that 9.81 meters per second squared. Then I have my height. And so the height I get on this one is going to be about 21.3 meters. So not very high, only about 65 feet above the surface, above the water in this case. All right, then we're going to jump down. We're going to do 7 and 8 as our last two. So we got an elevation of 5,334 meters above sea level. So we know our height is 5,334 meters. And Chile is the highest habitat town in the world. Gravitation potential associated with 64 kilogram person, so a mass of 64 kilograms. And remember, it's because we're here on Earth, G is still going to be 9.81 meters per second squared, and we're looking for potential energy. So this is the easy one, straightforward. Potential energy is equal to mgh. So potential energy is equal to my mass of 64 kilograms times the 9.81 meters per second squared times my height of 5,334 meters, not joules. Let me change that. Meters. And so we multiply all those together, and we find that potential energy to be 3.35 times 10 to the 6th joules. Okay, so quite a bit of energy. And then we'll do number 8. Peak of the extinct volcano of Chimborazo in Ecuador is at furthest point from Earth because the Earth bulges outward due to its rotation. Bulges greatest to the equator, which is only about 100 kilometers north of Chimborazo. Vulcan's summit is 6,267 meters. So I know my height, 6,267 meters. And we know a mass of 85 kilograms is the hiker that's climbing it. And again, we know G is equal to 9.81 meters per second squared. So I'm looking for my potential energy. That's my unknown. Yep. So again, same equation we used before. PE is equal to mgh. So my potential energy is equal to my mass, which was 85 kilograms, times my 9.81 meters per second squared, times my height of 6,267 meters above their surface. So when we do that, we find that our energy, or potential energy associated with this one, is going to be 5.23 times 10 to the 6th joules. Okay. Now you'll notice here, I'll kind of circle on, I did put all the answers to all 10, so if you want to go back and practice these, you can at least know what the answers are, so you can tell if you're right or wrong, and then ask questions for it. So hope this helps, and I'll talk to you later. See you later. Bye.